So let us see today's stack using single linked list. The operations here are push, that is insert the elements into the stack, pop, delete the elements from the stack, and traversing, that is displaying the elements in the stack. Now let us see the operations of stack using single linked list, that is push, pop, and traversing. So when we don't have anything in the list, the top will be is equal to null. It is similar to start in single linked list. Here we are taking the top because for stack the index taken as top, this top is equal to null. It implies that the list is empty. So whenever we want to insert a node in a stack, we create a node, some address, suppose some 152. This address is placed into the top and this is made as null. Again, whenever we want to insert, that is push into the stack, then we create another node and we will link this, that is 152 is stored over here. Some value is inserted into the list and this is made as top. Now next, again to insert that is push into the stack, again we insert front. This 111 address is stored. Again this top is moved to front. So that is for pushing an element into the stack. Pushing an element into the stack. What is the code we are using? We are using the insert front of single linked list. Now whenever we want to pop an element from the stack, that is we have to pop the element is whichever is the last pushed element. 6 is the last pushed element, so we have to pop this element. So I have to pop this element, that is delete front, that is pop top, again placed over here. That is whenever we want to pop an element, the code we have to use over here is delete front. Delete front of single linked list. And to display the stack elements, we use the display function of single linked list. Next is queue using single linked list. In this operations that we will see is enqueue, inserting an element into queue, dequeue, deleting an element from the queue, and traversing, displaying the elements of the queue. Queue using single linked list. In queue using single linked list, we take two things, that is front and rear. Front will be pointing to the front of the list, first of the list, and rear will be pointing to the last of the list. So these are made null because now the list is empty. First the front and rear are made null. Whenever we insert a node, first suppose we want to enqueue a node, that is insert a node, this element, and we place null over here 121. This node will become the front node and this node will become the rear node. Now whenever I want to insert a node, I will insert to the end of the list. Now this rear I will move to this node and link it. That is this null is replaced with 142. Now next again insert a node, that is enqueue a node, that is again create a node, that is create the space for the node in the memory, then insert the value and make this next as null because no next, and this address is stored, 152 address is stored into this node and it is linked. So that is we have to, for enqueue, we have to write the code for insert end. Rear will be pointing to the last node and front will be pointing to the first node. Again to dequeue, we have to write the code for, now which one I have to delete? The first inserted one is this, so I have to delete this, and front is moved to the next node. That is, we have to write delete front for DQ. And for display, again the display of the single linked list. This is the code to be written for Q using single linked list.